All right, guys, let's continue with our discussion today. So now, if you remember, you were working on your assignment, your homework assignment that's due a week from today, where you're doing two things. So you're building now a machine learning pipeline. The machine learning pipeline. Sorry, some people are coming in and I have to admit them. All right, so as I was saying, we are now exploring the machine learning pipeline from data in the web, which is really where you can get the most data available. All right, so you have the web and you're getting your data, and we're calling that data scraping. And that's what you're doing with your exercises of using, HTML, RSS. You're also using Twitter, right? So you're scraping data off the web, which is probably the best place to get data that, that you can actually use for for big data applications. Then after that, you saw in your code that you have to clean the data, right? And you saw what that means. I gave you the exercise of generating a plot, right? So I gave you the code already, and you have to kind of do like a histogram of the most frequent words. So the words are going to appear here, the most frequent words. But if you don't do the cleaning, this is just, you won't be able to define any insights in here, right? So if I see, a whole bunch of HTML characters or dots or things, and these words don't make sense, then, you're going to lose points for that. Instead, like if you did a political thing, this would probably say Trump, right? And this would say Biden, and this would say election. Currently, there's a debate going on. So it should reflect that type of data. If you did something about the hurricane, this would say, hurricane, Florida, Louisiana, I don't know, storm surge, something like that, right? So it would give you keywords that allow you to extract some insight. But for that to work, you have to clean the data after scraping it. So that's the first part of the homework assignment, right? That's just the first part, part one, let's call it, arriving at this. And you should have gotten that to work. If you haven't done so already, you need to let me know by today, today during class, ask questions, because you need to have that going. However, the next part is, getting the data to Weka or SKlearn to do some machine learning. Okay, so we want to get to do some machine learning, but the data as you have it here will not work for that. You just don't have it in the structured way that you need to have it, right? So here we just quick view of the data. Now we're going to proceed to what I've said several times is the vector space model. Okay, the vector space model is what you want to represent your data as, and then you need to define, labels. What are labels? You need to define that, and then finally you'll be able to do machine learning. Right, machine learning, and then finally, don't forget, you need to have results, right? So that's the metrics that we've covered already. And you do all of that with SKlearn or Weka. We're going to learn for now how to do that with those as we start progressing to the more advanced things. So one of the things I'm going to cover today is this, and I'm going to get into the coding side of it. There are many ways, many ways that you could do the vector space model, because that just relates to the features and everything. I'm just going to show you one methodology that can really quickly get you going. All right, but just be aware that there's more to it. So that's part 2, which we will cover today. For me to be able to show you that code relies on SKlearn, right? So it uses SKlearn. SKlearn is the scikit-learn library in Python. It's a library for science, right? Science kit. And so we're going to be using that one today. It's got a lot of built-in functions that can help us out. We're going to look possibly at pandas just very, very briefly as well. All right, we're going to be doing this in our Scholar, in our Scholar cloud. So get ready, get that ready if you'd like as well. All right, so that's what I'm going to cover now, and I need to start with, before I get to the actual vector space model code, I'm just going to go over SKlearn itself briefly. Okay, so before I continue, are there any questions? No questions, it seems. See in the chat. Oh, all right, no questions so far. Okay, so then let's go ahead and look at SKlearn. All right, so learning outcomes upon completion of this unit, students will have a better understanding of the SKlearn library, and you have yet for your toolbox of machine learning yet another tool that you can use, a much more powerful tool for automation. So what is SKlearn? It's as you know, you guys have taken a lot of Python over the years, so you've seen lots of examples of how we use Python for lots of things, right? For lots of things. And so here we're just using the Python libraries for machine learning. So this should say in machine learning. All right, so in machine learning, it is better to code. That's just, for obvious reasons, right? It allows you to do automation. It allows you to, access your code. You're going to be, Gweka is a great tool, I told you, for prototyping of your models, for getting a quick look of baseline models, etc. You've had some experience with that at this point. I would always encourage you, whenever we're doing machine learning, always run Gweka, SKlearn, compare the results, for your own sanity. Run it with Gweka, run it with SKlearn. Sometimes we'll be using the same algorithm in both. Compare the results. Okay, that's certainly recommended. Python has many machine learning libraries, many in fact. They're always competing. Facebook doesn't want to use TensorFlow because TensorFlow belongs to Google, so they use their own called PyTorch. And I'm sure Amazon, I think Amazon actually uses TensorFlow, but I'm sure at some point Amazon will create their own if they're not already doing that. So everyone is always, working on these things. And all of them are using gradient descent, which is the topic that we covered a second ago. So a lot of stuff going on, a lot of libraries, certainly. And here, this is why in this class, when Mitch did the presentation, the first thing he did, and he did a great job in the sense that he introduced Conda and he showed us how to do 2 environments. We have the TF1, the TF2, and you can create more environments. And actually, I believe he's going to create a third one called TF GPU, given that the TF2 version that we have only runs with CPU. We have this one that runs with GPU, but we need to have one with TensorFlow 2 and GPU. So I believe he's working on that. So anyway, we will have at least 3 environments, but hopefully by now you've learned some of the basics of Conda, the commands. If you haven't done so already, you should definitely do that. And maybe for this lab, you decide that you're going to create your own SKlearn environment in Conda and do everything there. Keep in mind that the versions, this is one thing that might drive you crazy in the beginning, especially if you do not do this with Conda. Because if you don't use Anaconda, you're going to end up with code that runs with one version and code that runs with another version, and you use this library, and then when you use this other library, it doesn't work. And so that's going to be, it's going to drive you mad. And so what you need to do is create Conda environments, always be aware of what libraries you're using in that environment. And if you do that, you're not going to have any problems, okay? For the most part, we're using Python above 3.5 really, anything greater than 3.5, but I'm just saying, one thing, be aware, as I start introducing more libraries, you're just going to have more opportunity to have errors of library things, especially if you start like doing pip and pip installs on just about anything, you know, you're going to have that problem. So definitely here, very strongly recommend that you always use Anaconda to create environments in your Ubuntu or in your Windows. All right, so TensorFlow is like SKlearn, but for deep neural networks. So that's another library that we will learn. So now you know at least 3 ways in which we will do machine learning, okay? There are other libraries like Pandas, NumPy, that we will use, but these are not so much for machine learning, they're more for data processing, pre-processing and all that. We've already done that one, and now we're starting this one, and then we're gonna start that one. Okay, and then you will see within this one, there's version 2, version 1, there's gonna be something called Keras. I mean, there's a lot of stuff, okay? But anyway, just be aware it's how it is, and in 2 years, they will probably update them significantly somehow. So, you know, certainly machine learning, especially, you're in a very exciting time in machine learning, and at the same time in a fast moving time. So you really have to keep with it, okay? So you can get SKlearn from that website, the scikit, sciencekitlearn.org. I believe Mitch has already, when you guys configured your Conda environments, I believe SKlearn is already installed. Okay. Now, in a lot of what we're going to be doing with SKlearn, we're always going to be importing libraries, right? That's a very standard thing. As you can see here, NumPy, we haven't covered it yet, but we're going to use it. You can see here, SKlearn is basically all of these, minus Matplotlib. And then we have SKlearn again here. Here's Pandas, more SKlearn. So as you can see, a lot of what we're going to be introducing is SKlearn. I'm not going to get into this yet, but we will get to it eventually. How to do the, you know, you already know what these are: recall, F1, precision, the confusion matrix. Matplotlib is a library for creating really nice graphs, so for viewing our data. So we will explore that later as well. Here we have some SKlearn things for the standard scaler, splitting the data. Just like you did the split in Weka, you can also do it here. We will look at that as we start going into SKlearn. Obviously, we're not going to cover all of this today, but we will begin with SKlearn. As you will see, SKlearn is actually pretty easy too. It's what I had said before. So I'm not going to spend a huge amount of time on it, because it's still very much as an object-oriented library. You basically create simple models, and then you can do a lot with it. It's not really that optimized for big data. So if you were handling 2 million records of something, I would strongly recommend using something else. And this is why we have to use like the big things like CUDA, CUDA-NN, TensorFlow, Pandas. The importance of those libraries is that they're meant for big data, huge amounts of data. But for what we're doing right now, you know, decent, you know, amounts of data, not huge, SKlearn does just fine. All right. So here are some examples of the things that we will be doing. So I think I talked about this some time ago, so I'm just going to quickly go over it. We talked about train test split. So obviously we need to have that whenever we have a data set that is X and Y, the vector Y and the X data. We're going to need to split it. And remember, we talked about X train, X test, Y train, Y test, right? And the size of the split that we want to do. So that's something that, you know, we will start doing soon. You always have to do this with your data, and there's just multiple ways of doing that. I usually, honestly, I like to do that outside of the script where I'm doing the machine learning, and I just always create a data set for train and one for test, for instance. I kind of like doing that, but you know, it's programming, so you can do a lot. All right, this is a very nice function, performance metrics. You can get this, you can just copy paste from the slides, or you can get this from my GitHub. It's basically the function that you will always use when we're using SKlearn or even TensorFlow to calculate the metrics. All you have to do is you give it the labels and the predicted values, right? So let's say you have the label is cat, cat, mouse, mouse, dog, cat, right? But your model, this is the real data, and then your model predicts, you know, 0, 0, 1, 0, makes a mistake there, 2, it should be 0, 1. So basically, it gets this one correct, gets that one, because this is the predicted, gets that one correct, makes a mistake here, gets that correct, makes a mistake here. So out of 3, 4, 5, out of 6, it got 4 correct. So 4 out of 6, that's the accuracy of your model, right? And so I have this nice little function kind of that I use, and you just have to call it. It's called print stats percentage train test, whatever name you want to give it. And it just, you can specify the algorithm that you're using so that it prints out nice results based on the, so when you're printing out your results, it makes it convenient. And then it basically takes, you know, Y pred would be a vector like that, Y test would be a vector like that. Take those two, and then you run them through all these built-in SKlearn functions, which are the ones that we got from here, right? So we run them through those functions, and it's just going to give you the results. So at the end of the day, it would give you that 4 divided by 6 for the accuracy, for instance, whatever that, you know, that calculation is like 80 something. Okay, so this function you will pretty much just use as is. I've already gone over the theory of these, so I'm certainly not going to go over that again. And then I'm not even going to type this up. I'll probably just say when we're doing the machine learning, I'm just going to go to GitHub, copy this function, paste it into my code, and go with it. Sometimes what will happen, I can already see this here, we're going to get little errors, okay? The reason being is that, you know, these functions, I've written these functions over the years, and sometimes they get updated to the version of whatever we're using. So just be aware that sometimes you need to add a little parameter here and there to get them to run, okay? But hopefully we'll do that in the labs, and so we will update if anything is missing. Okay? All right, so this will be our performance metrics function that you will use for your homework assignments and so on. Are there any questions about this function? you will always pretty much, when you're doing supervised learning, you will always have to do something like this. In whatever, these are all just kind of general things that you always do, right? Measure the performance and so on. Remember, this class is mainly about supervised learning. Is like probably like 70% of the class. I'm hoping to do like 15% of reinforcement learning, 15% unsupervised. But most of it will be supervised, so we're going to put a strong emphasis on these metrics. Okay. All right, so now, what are we going to do? So in SKlearn, since we're using supervised learning, just like you did in WECA, right? If you remember in WECA, you did like J48, KNN, logistic regression, I think multi-layer perceptron, and I remember you guys saying that it was taking too long, and I told you it's because it's not optimized for, for a lot of data. So SKlearn has the same algorithms, right? So SKlearn has the same algorithm. So for instance, it has logistic regression. You might notice that I always, whenever I start talking about supervised learning, I always start with this algorithm called logistic regression. Now, I'm not going to go into the details of logistic regression and how it works, because that is something that I do in the deep learning class. In the deep learning class, I describe every algorithm in a lot of detail, especially those algorithms that are function-based like these, but linear, and nonlinear. But I'm not going to get into the details of it in this class, except to say that this is one of the algorithms, a model, and then we're going to learn how to use it, okay? But, logistic regression is a simple algorithm that is often used by practitioners of machine learning because it can obtain good results. Okay, so I think I said this before. You don't need the fanciest, you don't need a, you don't need a, I don't know, a Tesla, right? You don't need a Tesla to when a bicycle will suffice, right? So you don't need such a powerful machine all the time when something simple will do. Sometimes you might have really good data, and if you have good data, logistic regression, which is fast, efficient, easy to train, might be the solution. So a lot of people will say, and I think I've given you these suggestions, like I always run naive Bayes because I've found that naive Bayes is fast. And so I like that, even though I have noticed, at least in my own experience, that it's always like the lowest result. So it serves as a baseline. A second algorithm that I always like running is logistic regression, because logistic regression is linear. So it's not, it's always a line, right? So remember what I said about, I like everybody, and I shouldn't say everybody prefers these models because they're linear, they're straight lines, they're simpler to train. They say that they generalize better than, say, if you had, right, a model that looks, like that. So those are a little bit more complex. And they do something called overfitting, overgeneralizing sometimes. So anyway, so logistic regression is certainly an algorithm you always want to run, okay? It's a simple algorithm that is often, it can be scaled to big data, which is great. That's one great thing, because you can implement it with TensorFlow and PyTorch and those in CUDA. And so that means that that simple algorithm can be there. It doesn't have that many parameters. It'll train fast and all that. But it's also available in SKlearn and WECA. And the recommendation goes for all of those. Always use it. It's not going to be like the multi-layer in WECA, which was very slow, although had a little bit more power to create functions like that. So it's a simple algorithm that is often used by practitioners of machine learning because it can obtain good results. It is a linear function, as I said, which basically means it's a straight line, much like linear regression. Linear regression, you guys I've probably seen that in your statistics class in linear regression. So it's interesting, right? It's the same idea, except that in linear regression, we are trying to fit a line to the data. In logistic regression, we are still trying to fit a line, but not to the data, right? We're not trying to do that. Instead, we're trying to fit a line that divides the data most optimally. So you're still in both creating functions, but the shape changes because of the goal. So linear regression and logistic regression are actually pretty simple. This is pretty much all I'm going to say about them because, as I said, these are topics that I cover in the deep learning class where we actually look at deep learning algorithms from, kind of from scratch and how they work and the foundations of them. But here, I'm only concerned with using things because we're, sort of starting more of on a top-down approach. I won't cover linear regression in this course, given that's something you probably covered in your stats class at some point. Just remember, linear regression was for predicting real valued numbers. And I think I told you this, or I said this before, like housing price. I have the square footage of a house, so the house should cost X amount of dollars. Whereas logistic regression doesn't do that. Logistic regression only predicts classes. So for instance, given this function, is it class 1, x's, or is it class 2, zeros? Okay, so it only predicts a limited number of things. Okay, so that's one of the things that you should understand. So logistic regression is a linear function, much like linear regression, which predicts the probability of a sample belonging to a given class. So you're going to say, I believe this image is 80% cat, 20% dog. So it's more likely to be cat. It's kind of that intuition. It uses another optimization function instead of the standard least squares functions used in linear regression. So don't worry about that. These are things that we will cover in the other class. And then it just provides probabilities between 0 and 1. So it determines the class that we want. However, okay, this is wrong. That should say SKlearn. Sorry. All right, so in the next section, we will begin to implement algorithms like logistic regression and other ones in SKlearn. Okay, in SKlearn. So here it is. This is basically, you don't have to worry about that for now, but that's the model of logistic regression. It looks like that, right? You have your inputs like iris. This would be x1, x2, x3, x4, and it learns a set of weights, right, that maps to the classes, class 1, class 2, class 3. If you remember, what were the classes of iris? What were the classes? Guys?
I think one was a Virginica and, am I right? Sentosa, yep.
Yes, exactly. So we have 3, Setosa, Virginica, and Versicolor, right? So those are the 3 types of classes, and that's what the model is learning. Given the input, it's going to learn a probability, 0.80, 0.2, oh, sorry, 0.1, 0.1. So which one do you choose? C1. You see that? That's what the model is doing in logistic regression. But at this point, just think of it from a point of view of intuition. Right? As I said, this will be covered in 5:30 for those of you that want to get into more depth of the deep learning algorithms themselves or the algorithms themselves. For us now, the focus is more on just using it. All right? So this is the basic structure that we will use in SKlearn. So let's take a second to kind of analyze this idea. Okay? So if you notice, what I've done here is I've created a function called logistic regression. The function takes X train, Y train, X test, Y test, right? So it takes the data, where after we do the split, let's say we did an 80-20 split. So 80% of the data is an X train and Y train, and 80% and 20% of the data is an X test, Y test, right? So I provide these four as the data. Okay, and then once I've done that, pretty much all functions in SKlearn are going to be written like this. Okay, they're going to be written like that, and they should be pretty straightforward to do. We will start exploring that soon. Okay, so what is the basic approach to use machine learning algorithms in SKlearn? All right, so what do we need to do? SKlearn is very object-oriented, and it kind of follows a very simple pipeline, if you will. Notice here, sometimes this will vary, but in general, it's going to be like this. We import the library. So we say from SKlearn, because logistic regression is linear, we look for linear models. And then from the linear models, we import logistic regression. So that brings us the class, right, the object. So now we call logistic regression over here. Notice that we set some parameters. For now, we're not going to worry about these parameters. We're just going to use the default values. You rarely have to change these. All right, so, and then that creates the object, which is, we're creating an object called logistic regression. Pretty simple, right? We now have LR, and LR is the algorithm, okay? Then what do we do from here? From here, then, we are going to take LR, and notice we do LR fit. Notice that LR fit only takes X train, Y train, right? So it only takes the two parameters. So what do you think is going to happen, is happening in LR.fit? What do you think? What's happening there?
I think it's given us just a regression value like X and Y.
So LR.fit, as the name implies, is taking X train and Y train and is training the model. All right, so at this point, you're taking that data, and the model was just a logistic regression algorithm without parameters. Let's say it looked like X1 plus X2 plus X, plus Xn plus B, right? That's what it looked like. You give it the data, and now after fit, you're going to have the values W1, W2, Wn. They're going to be defined now. And so now you're ready. You train the model, and now the next step is to call LR again, but this time you call LR predict. It's pretty intuitive, right? So LR fit, train the model. LR predict the model. So notice now that you do LR predict X test normalize. You see that? And the output of it is called Y pred. So what's happening there? What are you doing now? So you fit the model, right? You built the model, and now you do LR predict. What are you doing? YX test normalize. And what is Y pred? Keep in mind also that X test normalize is not just one variable, because if you just gave it one sample, that would be very inefficient, right? So it's actually a matrix of sample 1, sample 2, sample 3, a whole bunch of, right? And then however many, let's say you gave me 10 of these, now Y pred is going to give me a vector of also 10 predictions. Does this make sense, guys? You guys still there? Makes sense?
Yes, sir.
All right. Are there any questions? Nope. All right. So it seems like you're getting it, hopefully. All right. So then you fit the data, which basically means train. Train the model. Now you have a model and it works. Okay, predict. So let me give you a scenario. Let's say that you were building a translator, right? You want to translate from English to French. So what do? You give it examples of English and French sentences. You would do that here, right? In LFit. And you do that. Then you have the model, you put it on the web, you create a page, and you say, now go here and write your sentences in English. I'm going to translate them to French. So what's going to happen is LR predict would be called. You give it the French sentences, or sorry, the English sentences, and it's going to give you the French sentences. Okay, so that's what's happening there, and that can be for anything, you know, network packets, and you want to predict if it's an intrusion, not an intrusion. Images, you want to say if it's a cat or a dog. Face detection, pictures of people and places, detect the faces, you know, all kinds of things, okay? But it's pretty a simple model. LR fit, LR predict. Once you do that, we reference the function print stats percentage train test. If you look, that's the same function I defined over here. This same function, right? You just call it. And now you're going to supply to it two things. Notice here, you supply Y test, which is the real labels, and Y pred, which is what you predicted. So you're going to compare, given for the test set, right? For the test set where you had 10 images there, right? Of cat, dog, cat, dog, cat, dog. So you're gonna take whatever the real data is. That's what makes this supervised learning, right? That we have the labels. So this is the real data. And then this is what the model predicted, Y pred. And this function, as I showed in the example before, compares the two. And for accuracy, it would give you 4 out of 6, right? 4 out of 6. And that's what's going, but notice here that that's just accuracy score. We're actually also printing the other metrics that we discussed in the previous lectures. All right, so that's it. So that's pretty much how we're going to use SKlearn. It's not very, it's not actually very complicated to do. It's not very complicated to do. As you can see, it's a very simple format. And I usually just like to create different functions for different algorithms. If I have a KNN one, you know, I'll create a function KNN just so I can have everything kind of self-contained in there. Okay, but some of them will vary a little bit, but in general, the idea is sort of this one. Okay. So if you understood this idea, then you should be able at this point pretty much to start writing your own machine learning algorithms in SKlearn. So here you can see the, you know, kind of spelled out, provide, train, and test. Right, you need to provide, you know, maybe 80% of the data is trained, 20% of the data is test. Most steps will be abstracted in the algorithm. As you saw, it could not be simpler. In contrast, when we look at TensorFlow, you will need to define more steps. You have more power. In the function logistic regression, we define the logistic regression object, and then the key thing is that we have these two, LFit and predict. And then we measure performance by calling our handy performance metrics function. And, most algorithms, you can define functions in a similar way when you're using SKlearn. In the next set of slides, I'm just going to show other algorithms and how they also can be written. So this is just pretty much what I've said, so I don't need to repeat that. Neural networks, as you know, is that in WECA, that's that famous multi-layer perceptron that you guys implemented that took a long time to run. If you're a curious person, what I would do is I would take that same data set that you used in WECA and run it again in SKlearn with the multi-layer perceptron. I would put some kind of a timer or a stopwatch to kind of calculate which one runs faster. Remember that in machine learning, big data, performance is extremely important. It's something that, you want to get your results really quickly, right? So you don't want to wait several days to get your results. So certainly try it again in this context. Again, if you take the deep learning class 530, I will go into all the details of the algorithms. For now, in SKlearn, we're going to just look at it from a high-level view. But as I pretty much have said multiple times, the difference is that, it looks like this, whereas, so this would be logistic regression, whereas a neural net has the property that it can be more of a curved function like that, okay, more curved. And so in essence could be better, but this is harder to train. And sometimes it doesn't generalize well from the training set to the test set. Neural networks are very complex systems that take a long time to train. That's one thing that I wanted you to learn by doing that WECA exercise. Hopefully you learned that. Therefore, the use of them in SKlearn may not be recommended except for the smallest of data sets. So again, you can see that SKlearn might have a few limitations. That's why neural nets are the basis for deep learning. Okay, and we don't do deep learning in these libraries. So that basically means also don't do neural nets in these libraries. We're going to learn the big data libraries like TensorFlow, PyTorch, etc., which are all built on CUDA, at least in the way that we're doing it with the NVIDIA GPUs. Here the code is shown for contrast purposes only, okay? But the later implementations that we will cover this semester of neural networks will really be in TensorFlow, which is the optimal library for that. And then, as you will see in the second half of the semester, we will focus more on big data things. All right, here's the example for, as I said, for contrast purposes of implementing a neural network in SKlearn. Really, we're not doing anything. It's pretty much the same thing we did for logistic regression. We're just picking different libraries, right? We're just picking different libraries. So for instance, here, everything is neural networks code example. Everything is very similar to the previous logistic regression. The new changes appear in the definition CLF, right? Object. The parameter hidden layers is, now we have this idea of layers, right? Layers are the thing that give it a little bit more power, right? So the layers means that the architecture of the network consists of 2 hidden layers with 100 neurons each. So that's that idea that, if you remember, in logistic regression, the model looks like this. In a neural net, you're going to have neurons in between, more connections. Just like the brain, you know, they say like a bird has 1 billion connections. Let's say a human has 1 trillion connections, probably more than that. But okay, so just keep that in mind, right? So that's all that's happening there. So neural networks have that more capacity. Okay, so that's why you define that you have these hidden layers in between. However, we're not going to get too much into that here because we want to wait for when we cover better libraries for this. So we have 2 hidden layers with 100 neurons each. And that's how you code that. And if we just had a parameter like that one, 200 comma, it would mean that we have only 1 hidden layer with 200 neurons. So here, okay? But if you look, it's basically the same idea. We have called a function multi-layer perceptron. The inputs are X train, Y train, X test, Y test. All right, so that's really all it is. Then we call the library from SKlearn, notice now, neural network, import MLP classifier, multi-layer perceptron classifier. We define the object, you can see that here, and we specify the type of solver that we want to use, some parameters, alpha, the architecture, and so on, okay? For now in SKlearn, it doesn't really make much sense to go into all these details. So basically, we're just going to use default. Okay, default parameters just to kind of get an intuition for this. It makes a lot more sense to look at these things later. But keep in mind, these parameters are about, usually, if you remember that giant walking over those mountains, right? Those parameters are usually set to make this a little bit more smooth or more efficient. Once we've initialized the object, the CLF object, notice it's the exact same thing. CLF fit takes X train, Y train, right? Once we do that, we've built the model, and now we do CLF predict. For that, we need X test, right, which is the test set, and we obtain Y pred, the predictions. And then again, we call our very useful print stats percentage train function, and we provide the real data and the predicted data. And from that, we're going to make comparisons okay, so we're going to make extension, we're going to make, you know, the results. We can present the results. But if you notice, it's the same thing. Basically, it's 5 steps. Library, create the object, train it, test it or predict, measure performance. And that's your pipeline right there, right? That's your machine learning pipeline. Are there any questions about this, guys? No questions? Okay, well, let's keep going then. KNN. KNN is the nearest neighbor algorithm. This is one algorithm that I like. I like the fact that you can code it really easily. We will at some point, either using NumPy or TensorFlow, we're going to code it from scratch, okay? But it's another algorithm. I think it was called IB1 or IBK in Weka, right? And here it's called KNN. It's the K nearest neighbor classifier. It's a popular algorithm that I always like to use. It's a very interesting one because it works in a different way. than some of the other ones. So I usually like to cover the details of it, of this one here, but I'm not going to do that today. I'll do that later on in the semester. Once I know that we have time for that. It requires very little parameter tuning and can be easily implemented. Here, the SKlearn base code is similar to all previous approaches. The new aspects relate to the K and N parameters such as the value K. So what is the value K? Basically what you do with K and N is that you compare, you have a whole bunch of things, right? A bunch of things, and then you have a sample. In the space, you calculate the distance between the sample, the square, and all the other samples. Notice that. And I'm comparing the distance, you know, how far away it is. So then once I have all the distances, notice here I'm going to have 7 distances. Then what I do is I rank the distances from shortest to longest, right? So it's going to then take, you know, distance 5, 6, 6, 7, 8, 9, 10, right? So it's got all of these distances, and then K determines the number of the how many of the shortest distances do we pick. So for instance, if I say 3, I'm only going to look at these 3. So what I do is I determine, okay, that's this one, that one, and that one. Those 3, right? And I look at the labels, and if I look, oh, okay, 2 of them are zeros, 1 of them is X. So therefore, what class do I assign? Do you think? Intuitively, with K and N, which class would I assign? 0 or X? Zero. And somebody said 0, and that's exactly right. So that's how simple this algorithm is, okay? It's very simple. It's not very efficient because you have to perform this calculation for all the data. Imagine if you have 1 million samples. However, it's something that could be parallelized, I guess. So in that sense, that's doable. All right. But anyway, that's K and N. We will cover it in a little bit more detail later in the semester. What's important for today is, again, how would we write our K and N function using SKlearn? Pretty simple. Call it K. Notice that I put RC there. It's my initials, right? So the idea is that these are functions that you define yourself, however you want them. Notice again, same pattern. X train, Y train, X test, Y test. Okay? Then after that, import the library, in this case, K neighbors classifier, instantiate the object, okay? Some parameters, Minkowski distance function, you know, how do you calculate the distance? Number of closest neighbors, 5, 3, or whatever. Don't, you know, because don't use even numbers, obviously, because you don't want to have a situation where 2 are one class and the other 2 are the other one. Instead, pick an uneven number. And then after that, you do K and N fit, train the model, and then K and N predict, and you predict labels. Then you have the labels are Y test, right, and Y pred. So Y test goes there, Y pred goes here, and now we call our handy print stats percentage train test function, and that will give us our results. As you can see, this is starting to get pretty repetitive because it's a very, very similar approach. Okay, so that's another algorithm, K and N. Are there any questions on K and N? All right, so it seems there's no questions. So let's move on to yet another algorithm. I think this is the last one. Yeah. So I'm just going to introduce here support vector machines. Again, I'm not going to go into all the details. This is just another algorithm. Historically speaking, before deep neural networks came into the scene in 2012, the whole landscape was dominated by support vector machines. It's a very mathematically appealing technique, and so people liked it because of that. It's very well founded on some principles. So it was one of the big boys in the block, right? You know, it's a very, mathematicians really like this algorithm and all of that. So it was very well respected by machine learning practitioners, and they used it a lot. But you know, the reality is that the world is economics, and deep learning beats every single SVM out there, and so the algorithm has become displaced. But who knows? Maybe someday there will be something else that displaces deep learning algorithms. So that's certainly possible. All right. So all right, so I'm not, you know, the next slides cover the framework of SVM. I'm not going to go into the details. Here are some references. If you guys have an interest in reading about them, go ahead and look for those papers. I'm going to skip this, as SVM at this point is not the most important algorithm in machine learning. But the important thing is this slide here, which again tells us how to use SVM. It's still a good algorithm, right? Compared to, say, logistic regression or KNN or naive Bayes. It's just not better than, say, the deep learning algorithms. All right, so here I have another one, SVM-RC. Again, same principle, X train, Y train, X test, Y test, right? So I have my 4 data sets. Pretty much the same thing. Bring in the library, create the object, instantiate it, default parameters for now. We don't have to worry about this. And then, same thing. Give it the X train and Y train, right? The train data, 80% of our data set, samples and labels. Train. You're going to do the fit. Once you do that, then now you use the model, you predict. What do you predict? Give it X tests, right? The X data is going to give you Y pred, the predictions. And then, should be no surprise by now, called print stance metrics. That takes Y test, the real labels, and Y pred, the predicted labels, and it's going to compare them. And this will report your precision, recall, F measure, and all of those good old functions or result metrics. Sorry, metrics. All right. Are there any questions on any of this, guys? All right, so hopefully this makes sense. This is the simplest way that we can write machine learning in Python, just using this model. Pretty easy. Obviously, we're going to look at many other techniques. All right, so now hopefully you have some intuition of how to do these. So let me now go back. That's the last slide here, I believe. So now let me just go to what I want to do today. So I'm going to add a new slide here. Right. So now what I've done, going back to what I started with in the pipeline, right? So you guys are going into the web, getting some data, right? It's called data scraping. Then you're going to clean the data. You're doing that. And then you're doing that insights, right? You're going to visualize the data, visualize to create that little graph. That's part 1 of your homework assignment. Okay. That's part 1. And that just gives you, you know, for all the words, you know, I said Trump, Biden, election, and so on. But that's just data visualization. You haven't actually done any machine learning. So now we got to work on part 2. Part 2 means creating a model. and then the metrics. I already showed you how to do that with SKlearn. So you knew how to do that with Weka. Now you know how to do that with SKlearn. Pretty simple. You give it the data, split the data into train, test. So, but we're missing a component, at least 2 boxes. One box is the split. That's easy, right? Go from X and Y to the 4. X, train, train, X test, Y train, Y test, right? So I showed you how to do that. So you're going to split the data here, right, into 80, 20, or whatever. We've already kind of seen how that's done. But before we get to that, you need to do this part. And that is taking all this abstract data, all of this crazy data that you have, figure out what your labels are going to be, figure out what samples are going to be. So you need samples, labels, features, right? So you currently need to define all of that, right? You need to define all of that. And given that, you're going to create the vector space model, okay? The vector, vector space model, all right? Which will capture the result of which will be X and Y, right? In a format, CSV maybe, comma separated, that allows you to do machine learning. So obviously a lot of work probably needs to go into that. What I want to show you is just a quick way, a really quick way of getting that going, especially because the data that you're getting is text, right? So you're scraping HTML. You're not really using the images. You're only using the text. You're scraping text. You're going to scrape text from Twitter, text from RSS feeds, text from HTML. So you basically have text in there. And so we're going to take, that example to represent the vector space model. And then my goal is that you will be able to do supervised learning. Now, you will also need to have labels of some kind. Make it a 2-class label problem. But ultimately, we want to get the homework, this homework, part 1, part 2, I need to see metrics. I need to see precision, recall, F measure. You will do everything with Weka and SKlearn. But the hardest part, if you thought this was hard, you still need to do this, right? So I just want to give you a very simple example of how to do this in SKlearn. Okay, so you can use Scholar or you can use your Windows for the sake of simplicity. I'm just going to use the Anaconda environment with Windows here. So let me bring up, actually, let's use Scholar. I want to use Scholar. Let's do that. So hopefully we all remember. Mitch, if you're there, can you be ready to help us out? What was the address to get over there?
I'll put it in the chat right now.
Okay, thank you. Yeah, if you don't mind. So let's follow, let's go back to our Scholar environment. So click on that. And you will need to use the your boiler key. Okay. and then remote desktop. All right. Hopefully we'll get into the environment. Click on quit or OK, sorry, you have to click on OK. All right. So now, so Mitch gave us the Scholar, so you can all follow along. Now I'm going to share, hopefully, my Scholar. All right, so you guys should be seeing my Scholar environment in here. Okay, so now what I'm going to do is I'm going to go into the terminal emulator. All right, there we go. And I believe Mitch said that we needed to type bash to get the Conda environment. There we go. So you should, are you guys seeing my terminal? I'm going to assume that's a yes.
Sorry, I was on mute. Yeah, we can see it.
Okay. So, all right. So now what we're going to do is we're just going to create a simple script for the vector space model. All right. So we'll be using this as a simple example. So I'm going to do desktop. Okay. And I'm going to create a folder here and call it 520 just because I don't want to have the scripts all over the place. All right, so now I'm going to navigate into that. All right, so here I'm just going to create a little file. You can use any editor you want. I'm just going to use Nano here. And I'm going to call this one vector space model.py. All right, here we go. Notice that I haven't gone into any Conda environment yet, but I'm going to just start looking at the code, okay? So first of all, you know, I'm going to import SKlearn. And so it's kind of the first step. Put a line there. All right, then after that, I'm going to need to specify some data. So let's say that you have some data here. I'm going to create a list of strings. And this will represent your samples, for instance. So information that you got from your RSS, your HTML, your Twitter. You know, maybe it's a tweet, right? So let's say it's a tweet. So I'm going to just write some things. I'm going to say machine learning is super fun. Right? So that's one sentence. All right, I'm not going to write too many sentences given that I'm short on time. I'm just going to write like 3, but you can have as many as you want. Python is super cool. Right. And then finally, oops, I missed a double quote there. And then here, I'm going to do, and you can always just add more sentences to make this more meaningful. Statistics. Is cool too. all right, and so on, right? So I have 3 sentences in here. I can add more if I need to. All right, now that I have that, I'm just gonna say Control X, Y, all right? I'm gonna open it again. All right, I have my little example there. So this is actually very short code. It's not like it's a lot, but it's a quick way to get the vector space model going, so creating the features. So what I'm going to do is I'm going to create something called vectorizer. And vectorizer basically means I'm going to take my sentences and convert them into vectors. In fact, I'm going to use an approach called the bag of words approach. Okay, it's a very standard approach to really quickly convert something into feature vectors. So because we want to do that, we can create an object called vectorizer that creates vectors. And all we need to do is call a module called countvectorizer. Countvectorizer, okay? So that's what we're going to be using. Countvectorizer has some parameters that you're going to have to play with. And we're gonna, one of the parameters is min df, which we're gonna set to 1. That parameter means that we're going to pick words, right? So we're gonna pick the words that we see in example, and each word will become a feature in our vector space model. So then after that, the bag of words approach basically means that whenever we see the word, we're gonna count how many times we see that word in the sentence. So we're gonna represent each sentence, each one of these 3 sentences as an equivalent vector made up of these words, okay? I'll explain more of it later, but for now, I just wanna give you the code, and so we will come back to that in a sec, right? But once I've done this, I also wanna specify that the stop words are going to be English. What that means is that there's a lot of sentences or a lot of words in English that appear in every word. So for instance, like is, the, right? So those are words that provide very little meaning. And so we can get rid of them by saying stop words equal English. It basically means ignore stop words. Okay. Once I've created, oh, that should not be commented out. Once I've created vectorizer, I'm just going to apply it basically. So I can create now an object, DTM, let's call it, and that's going to be what contains my data. So I'm going to call it vectorizer, and notice I'm going to do dot fit. If you remember, when we were looking at the slides, we would do fit and then predict. Sometimes you can actually do both at the same time, and that's usually when you do something called fit transform. So we perform both operations at the same time. And we're going to need to apply this to example, right? So we're going to apply it to our example data, which is the one at the top over here. So we're going to take these sentences and convert them to the vector space model. So I'm going to save this. All right. Go back to it. And now the last part is we want to print the data. So to print this data and to view it, I'm going to use pandas. So remember, I'm kind of just throwing pandas at you. And you know, we're just using pandas is really good for like data visualization, processing. So we're going to use pandas data frame. All right, and we're just going to view our data. So I'm just going to here specify some parameters, okay? So I'm going to go kind of quickly here, but it will be useful to have this. One thing is we're going to take whatever's in DTM and make it into an array. Okay, we do that first, right? So it's a type of an array. Then we're going to specify what we want to be the rows and the columns, right? So for that, we say index should be equal to example. So that means that for every entry, we'll be able to show the original sentence and the vector of it, right? So that's why you can do index example. then the columns will be the feature names. All right, so we're going to say, for instance, vectorizer dot get feature. Did I spell that right? No. Feature names. And then parentheses there. Feature names. And then after that, here, I'm just going to say that I only want the top 10 words, although we probably need to have more sentences to even have 10 words here. But I'm just kind of quickly going through this. All right, so columns equal vectorizer dot get feature names and then head 10. Right, so that should be correct. And that's it. So sorry, we're kind of only have 4 minutes left. So I will continue this, I guess, explaining the bag of words and everything in the next class. But at least right now, I've given you the code so you can play with this for your homework assignment. All right, so one other thing you can do is do vectorizer dot get feature, feature names, and that will give you the names of the vectors, okay? So the other thing that's missing from this is that now we need to import some things from SKlearn. So one of the things we need to import is from SKlearn feature extraction dot feature extraction dot feature extraction dot text. We're going to import count vectorizer. Okay, and also I use pandas, so I need to import pandas as PD, I think, which is what I was using down here, I believe. Yeah, PD is there. That's pandas, okay? So let me also reduce this to 5. All right, oh, sorry, not 15, 5. All right, so if I'm kind of really quickly going through here, but let's see if this will run. This is the code that I want you to use for the part 2 of the assignment. So we need to do conda environment list. Okay, so I'm going to assume that TF1 has sklearn. So I'm going to do conda environment, no, what is it? Conda activate, sorry. Conda activate ITS520 TF1. All right, so I'm in my environment now. And then let's see if this will run. So I'm just going to say Python. Okay. Vectorize invalid.
You have a bracket misaligned.
Do I? Okay, sorry.
The line with the DTM, at the end, you have the bracket there. It should be moved up.
Oh, yeah. What happened there? That's interesting. All right. Yeah, thank you. So this should probably go down here. I don't, this weird thing, it's like blocking my view. All right, so let me try it again. Ah, there we go. Look at how nice that looks. All right, so so I'm sorry that I'm a little bit over time, but just quickly, this is what, at least with this, you have something to do machine learning. Because if you think about it, I took the sentences, machine learning is super fun, Python is super cool, statistics is cool too, right? And that's the original sentences, but here on the other end, now I have the vector. So I created vectors that have the words cool, fun, learning, machine, Python, statistics, super, right? And so all that's happening is that those are the features. So they're really feature 1, 2, 3, 4, 5, 6, 7. And that's called the bag of words approach. Next week, I will get into more of the details of the bag of words approach and explain the algorithm a little bit more. But at least now you have this to work on your homework, okay? So what you can see here, what happens is that you represent the sentences as what are called very sparse vectors. Notice, for instance, that the last one, statistics is cool too, is mostly zeros, but it's got a 1 for cool, and it's got a 1 for statistics. Now, the word 2 did not make it into this, possibly because I said only print 5. Maybe if I had said print 10, 2 would have been in there. I think it's a common word. Notice that the sentence Python is super cool is represented by cool 1s, Python 1s, but the word super appears twice, right? It's super cool. Machine learning is super fun. You can see here, cool does not appear, fun is there, learning is there, machine is there, Python is not there, statistics is not there, super is there. So what's important here is that you have vectorized your problem. You will do this always, whether it's images, network data, you know, whatever you want to do, you always need to vectorize it. Notice that the feature for every sample needs to be the same. So the first column is cool for everybody, and just some contain it, some don't. Fun, the same thing. You know, some contain it, some don't. Learning, and so on. This is a very standard thing. And then the last part here is I just listed the features as well, okay? And I guess it seems like 2 was not included. It might be a stop word, and that's why it's not there. Does this make sense? So I only did this with 3 sentences. Obviously, you're gonna have a lot more, right? Because you have your RSS feeds. And so now you have a way of taking maybe tweets, RSS feeds, HTML, vectorizing them. So this certainly would fit in a machine learning. In Weka or SKlearn, this will fit there nicely. Given that I didn't do that so much with SKlearn today, we're gonna change the homework so that you only have to do machine learning in Weka, okay? Because I guess I expected to have more time and I didn't. But you can do this with Weka. The only problem is, what's the problem here in supervised learning? You have samples, but what's missing? So you have the features, what's missing here? The labels, right? The labels are not there. So if you have samples like machine learning is super cool, Python is super cool, statistics is cool too, what labels do you want to have? And how are you going to code those labels? So I leave that to you, but it could be, for instance, that, you know, you collected political HTML sentences. And so one says, you know, GOP looking at court, Supreme Court confirmation. Then you have governor from this state talks about this. Trump doing something in the election. Then you have another set of sentences that says Biden visiting Pennsylvania. Some other person doing this. That's a Democrat. Democrats doing this. So the point is you could hand label some sentences as being Republican, other sentences being as Democrat, right? And that would give you labels. So keep in mind that that's missing in this approach. This is only the X data. You're missing the Y data, which means that for each one of these lines, you have to assign a label. And I leave that to you guys to figure out based on your problem. Once you have that, you should be able to do machine learning. All right, guys? So that's the second part of the homework. So hopefully all of this is clear. Go ahead and work on this. Send me an email if you have any questions. And so this will be due next Thursday, next Monday, right? A week from today. That will be your homework assignment, which is basically to complete the pipeline and obtain your results in Weka. I will post a link on Brightspace that will provide more of those definitions I just described. But anyway, so that's kind of what I wanted to give you today, the vectorizer. I will explain this a little bit more when we come back on Monday. All right. Are there any questions?
Oh, just don't forget to please post that one on
Post what? Sorry.
this lecture.
The videos, yeah, I always post it in the channel, right? So that comes really quickly. The link might take me a while, but will
Are you gonna post the code or?
Yeah, so somebody asked me, will you post a copy of this code? Well, it's gonna be in the video for sure. But
You wanna copy and paste it and send it to you, Josh? I'll put it in Discord or something.
yeah, so I think I have these in my GitHub also. So I'll try to find the link for that. The other question is, we need to add this code to existing collect data code for assignment. I think what that question means is that, yes, you need to use this code for your homework assignment, right? After you've collected the data and seen the little graph, you're gonna have to pick probably sentences in your data, vectorize them kind of the way I did, put labels in there. So you're gonna have to hand label at least 100 examples. I suggest you make it like, what do you call it? Balanced, so that 50 are Democrat, 50 are Republican. Pick a topic that you want, whatever you're interested in, and then you're going to, because we didn't have time to look at SKlearn as much, you can just do it in Weka. That's fine. Questions? All right, no questions it seems. All right, guys, so we're gonna stop here for today, and I will see you 1 week.
A quick question.
Oh yes, please, sir.
How many labels do you want?
You mean like you could do, for instance, Democrat, Republican, Independent, or Democrat, Republican, right? That's what you're asking?
Correct.
It's up to you. It's entirely up to you. It's up to you guys. Just make sure you have a data set of at least 100 samples. Now, you don't have to write the sentences manually because they're coming from your HTML or RSS, right? Does that answer your question, Josh?
Yeah, that sounds good.
Okay, great. Any other questions, guys? All right, seems like there's no questions, so we'll stop here for today, and I will see you guys in a week. Enjoy your assignment. Should be fun.